To do a two-way between subjects ANOVA, you need two independent variables that are between subjects and a continuous dependent variable. So I'm going to be using gender that has two groups for my first independent variable. And then I'll be using section, which has three groups, as my second independent variable. I'm going to see what effect gender and section of class has on final percent grade. To do this, you go to Analyze, General Linear Model, and then Univariate. In this dialog, you can also do a one-way ANOVA. That is an ANOVA that only has one independent variable. And it has some additional features that you can't get through the other way of requesting a one-way ANOVA, which is through the one-way ANOVA command. So first, you just put your dependent variable, final percent grade, in the dependent variable box, and then you would put both of your independent variables in the fixed factor box. In this video, we won't worry about random factors or covariates or weights. After this, you should request all possible plots between your variables. And to make these plots, you generally start at the top, and then the more variables you have, you add each variable to each box here. So I'll show you how this is done. You add gender to the horizontal axis. When you press add, once it's added here, SPSS knows that that's the plot you want to create. So you create one for each of the effects that you have. So we have a main effect of gender, a main effect of section, and then we have the interaction between the two. When you have an interaction, you have to plot both of these. So it's a decision of which one you put on the horizontal axis. And essentially, anytime you have a factor that has a larger number of levels, that's the one that you want to put on the horizontal axis because it will make it easier to interpret. So because section has 3 levels, I'm going to put it on the horizontal axis, then add gender to the separate lines, and then press add. So this will give us the interaction plot. Then you press continue. In the options dialog, you have to click off 4 different items. The first one, descriptive statistics, effect size, observed power, and homogeneity. Because this is an ANOVA that is using between subjects independent variables, you need to know you need to do a test of homogeneity of variance. So then you press continue, and then press OK. So at the beginning of the output, it's going to give us a review of how many participants we have in each group. So for gender, we have 2 levels, and section we have 3 levels. So this would be a two-way between subjects analysis of variance, and you would call it by the number of levels. So this would be a 2 because gender has 2 levels, by 3 because section has 3 levels, ANOVA. A 2 by 3 between subjects ANOVA. The second piece of output you get is the descriptive statistics, which is just the means and standard deviation and number for each condition. So because we have a 2 by 3, we have 2 times 3 or 6 different conditions, and here they are here, 1, 2, 3, 4, 5, 6. The bottom line here is what tells you the total for females across section. So basically collapsing across section for all of these numbers. And this is the total for males. And if you want the total for sections, for example, if you had a main effective section, you would look at the totals down here. Next, we have our Levene's test of equality of error variances, or homogeneity of variance. This is interpreted in the same way, and I've already made a video on this. So this is significant because it is less than 0.05, which means we cannot assume equal variances, which means that if we had to do post hoc test, then we would choose Bonferroni. instead of the default, which is usually 2 key. Next, we get our test of between subject effects, and this is our ANOVA table. So here we have our 3 different effects. Because this is a two-way ANOVA, we have the main effect of gender, the main effect of section, and then the interaction between the two. And looking at the significance values, we can see that essentially none of these are significant because none of these are below 0.05. After that, you get your means plots, one for each main effect, and then the interaction. And although none of these are significant, so I don't need to do anything further, I'm going to show you how to do a post hoc test with one of these variables. So let's say that I'm going to do a post hoc on section. So to do this, you go back into the univariate dialog, and it will remember everything that you've placed here. And this time you press the post hoc button. So I'm going to request post hoc for section, so I move this over, and then I simply select the one that I want to use. There's various reasons why you would want to use each of these, but in our class we're just focusing on 2 key if you do have homogeneity variance, and Bonferroni if you do not have homogeneity variance. So I'm going to click Bonferroni and press continue. Then press OK. All of the output it gives us is going to be the same. The only new piece is this multiple comparisons table, where it looks at the pairwise comparisons between each of the levels of section. So unsurprisingly, there are no significant differences, and that's because section was not a significant variable to begin with. But this table is what you use in order to interpret the pattern of effects if a variable is significant and has more than 3 levels. And that's it for a two-way between subjects ANOVA.